Today, we are heading to Australia, specifically off the east coast of its major island of Tasmania. There, 65 kilometers east-northeast of the city of Hobart, we reach Maria Island, which comprises Maria Island National Park. Here, we can find a wide range of interesting geologic features, from unusual igneous pillars to colorful chemical weather bands, a missing 100 million year gap in the geologic record, and many fossils. So many fossils, specifically seafloor fossils from the early Permian period dating back 280 million years ago. Today's video will discuss this fascinating island's geology and how it formed, along with explaining some of its more unique features. Also, random kangaroo, and now 2 species of smaller marsupials attempting to raid camp equipment. And now, we start at the beginning when the oldest of the now many exposed rock units started to form on what would later become Maria Island. This means we are in the early Silurian period 440 million years ago, when rock units that would later become Maria Island were situated a mere 120 kilometers north of the equator in the northern hemisphere. It existed at the bottom of a continental slope. As a result, when large underwater currents swept down that slope, it carried with it many fine particles of sand and sediment via what are known as turbidity currents. These turbidity currents, which continued across the next 80 million years, lithified over time to become a rock type known as quartzwacke. During this period, intermittent igneous intrusions of rhyolitic composition magma occurred, which would eventually solidify as granite. This formed multiple outcrops that are today exposed on the southeastern portion of the 2 major island segments. These rock types were eventually uplifted above sea level, along with being tilted and folded as they were compressed on an eastern portion of the new supercontinent Pangaea. However, what rock units were deposited during the Carboniferous and part of the Permian were removed at some point, creating what is known as an unconformity. On the bottom, we have tilted quartzwacke or granite from the Silurian and Devonian periods, while at the top we have limestone and some sandstone dated to the early Permian period around 280 million years ago. Depending on which part of the island you are on, the unconformity represents a geologic gap of between 60 million and 100 million years and is locally known as the Great Unconformity. In the shallower, lush ocean environment of the later Permian, this part of Australia was almost literally at the South Pole. But that did not stop widespread shelled sea creatures from living in these waters, resulting in the deposition of many fossils. In some spots, they are so numerous in exposed Permian limestone and shale that you cannot possibly miss them. These rock units ended up becoming exposed on the middle third of the northern segment of Maria Island. We next have evidence of an ocean regression, as during the Triassic period the relative sea level dropped and sandstone was deposited from many sand grains, forming the absolutely stunning sandstone cliffs. During the early Jurassic, large volumes of low silica magma solidified at depths of less than 2 kilometers or 1.2 miles, forming a rock type known as dolerite. This magma eventually solidified, but much like a ponded surface lava layer, the contraction it experienced was most easily accommodated by naturally forming polygons, which then propagated from the top down. This rock unit is exposed on the highest parts of both island segments, along with these brown-colored segments to the west. No currently exposed rock units would then develop on Maria Island until 20 million years ago, when erosion of iron-rich material from the dolerite eroded downwards, allowing for ferrocrete to form. This iron-rich material later ran off onto the painted cliffs, staining them and creating colorful bands of coloration. A long-term chemical reaction created what are known as Liesgang rings, which can be easily seen here. The final rock units formed during the last several million years, adding significant sand that connects the 2 island segments. As a final note, I would like to thank my patron Peter Lawler for taking the majority of photos and videos used in today's video, and who requested that I cover this geologic topic.